Alright, welcome back. So far, every time we wanted to run our system, we opened multiple terminals. One for publisher, one for subscriber, maybe another one for a service, and another one for an action. That works for small examples, but in a real robot system, you might have 10 nodes, 20 nodes, sometimes even more. So starting them manually becomes painful, slow, and error prone. That's why ROS2 provides launch files. Launch files allows us to start an entire system with only one single command. So, in this module you will learn why launch files are essential, how to create Python launch files, how to start multiple nodes together, how to pass parameters, how to use launch arguments, and how to structure launch files properly. Launch files live inside a launch slash directory in your package. This is the convention. You should now see a launch slash folder inside your package. Launch files in ROS2 are written in Python. They define what nodes to start and how to configure them. Let's create our first launch file. Let's break this down. First, we import launch description, node from launch ROS. Inside generate launch description, we create node objects. Each node defines the package, the executable, the node name, where the output goes. Finally, we return a launch description containing all nodes. That's it. A launch file is simply a structured description of what to start. Creating the launch file is not enough. We must tell ROS2 to install it during the building process. If we skip this step, ROS2 launch won't find the file. This line ensures that all .launch.py files are copied into the install space. Without this, ROS2 cannot discover your launch file. These dependencies ensure that the launch system is available at running time. Now let's build everything and test it. Notice something important. Both nodes start in the same terminal, and when I press Ctrl C, everything shuts down cleanly. This is how real ROS2 systems are managed. Launch files can also pass parameters to nodes. This allows you to configure behavior without modifying the code. Now rebuild and relaunch. Parameters are fixed inside the file, but what if we want to configure the system from the command line? That's where the launch arguments come in. Now the publishing rate is no longer hard-coded. It is configurable at launch time. Let's test it. This makes launch files reusable and flexible. Large systems are modular. Instead of one massive launch file, we include smaller ones. This allows hierarchical systems composition. It's extremely common in robotics projects. Launch files also allow topic remapping. This lets you redirect communication without changing code. This is powerful for integration and system level architecture. So in this module you learn launch files starting multiple nodes with one command. They are written in Python. They must be installed via setup.py. You can pass parameters, you can declare launch arguments, you can remap topics, you can include other launch files. Launch files are not optional, they are essential for any real ROS2 project. In the next module, we'll move into robotic modeling. We'll start describing our robot using URDF. That's when our system starts to look like a real robot.